Bismillahirrahmanirrahim. In today's video lecture of Advanced Communication Networks, we are going to start second chapter of our textbook named Computer Networks, a System Approach, with a problem connecting to a network. So first we need to define a computer network. As we know, computer network is a set of network devices connecting together for the purpose of sharing resources, and these resources are in the form of hardware, software and data. However, through computer networks you can connect two or more than two devices. More than two means you can connect 100,000, even millions and billions of devices. However, what would be the simplest possible form of a network? The simplest possible form of a network start connecting two devices or two nodes through some suitable medium. For example, if you have two computers or you have two laptops and you connect those particular laptops through some suitable medium like a UTP cable, so that would call the simplest form of a computer network. So after connecting these devices with each other through direct link, what are the possible issues in this particular network? There are basically five issues. First, the first important issue is what should be the form or pattern of binary bits that are going to transfer between the nodes in a meaningful way. In a meaningful way means that the receiver could easily interpret that bits. And we will cover this issue in encoding topic. The second possible issue is what should be the boundary for a series of bits so that the receiver can process data in a form of chunks. And we will cover this issue in a framing topic. Framing basically provides a way for sender to transmit a set of bits. So how many bits will be there in a single frame? So we will cover these chunks of data in a framing topic. Third issue is error. While sending the data or simply bits from the sender to receiver, there is a high possibility that the data may get lost or get corrupted. Or we can say there is a possibility of errors, that errors may occur. Error is a situation when the sender's data doesn't match the data at the receiver end. And it can be a 1-bit error or burst error where more than one bit get corrupted, or we can say mismatch at the receiver end. And we will study this issue in the error detection topic. The fourth issue is if an application requires reliable transmission even in an unreliable network. So how this unreliable network, what is the technique and what are the techniques or mechanism that make the unreliable network suitable for reliable transmission? And we will cover this issue in a reliable transmission topic. And finally, the last issue is on the link layer, or we can say if multiple nodes are transmitting simultaneously on a single link, so how this phenomena may take place. And we will cover this topic on the medium access control with this issue on the medium access control topic. And there are various schemes like CSMA, which is called carrier sense multiple access. There are some Ethernet scheme, token ring schemes and wireless schemes in the form of CSMA, CA, and we will cover all these issues one by one on a data link layer. As we know, OSI model is used as a reference model in computer networks. Therefore, we will try to map these 5 issues with reference of OSI model, and we will also figure out the software and hardware aspect of these issues. As you see in the OSI model, the upper 3 layers, application, presentation and session layer are implemented in the user level software. The middle 2 layers, that is transport and network layer, are implemented in the kernel software, or we can simply say device driver. The lower 2 layers, that is data link layer and physical layers, are implemented and the hardware, or we can say network adapter, are more simply say network interface card. So let's map our 5 issues here. Encoding basically occurs at physical layer. Our physical layer is concerned with encoding, while data link layer is concerned with framing, error detection, and medium access control. However, the reliability issue can be handled at the data link layer or at the transport layer. However, if you have to choose one, then you may choose transport layer for reliability. However, these issues may be handled on some other layers as well. Like error detection, sometimes you can handle error detection at network layer as well. So, encoding, physical layer, framing, error detection, and medium access control, or maybe reliability at data link layer, and transport layer is for reliable transmission of data. So, hardware building blocks of a computer networks. In hardware building block, the first building blocks are in the form of nodes, and nodes are further divided into host, switches, and routers. Hosts are basically general purpose computers, or we can say your PCs or laptops or smartphones nowadays can be counted in hosts. Switches are typically special purpose hardware. Through switches you can connect multiple hosts with each other, and you can further connect switches with each other, or router can be used to connect different switches. So routers are used to connect network segments. Then in the hardware building blocks we have links. In links we have a variety of links. It may be a guided medium or unguided medium. In guided medium we have links that are connected through some physical wires like copper wires, UTP cables, we have glass fibers. In wireless we also have a variety of possibilities, like we can connect through radio, infrared, microwave, and even satellite. First we need to define that what should be the possible architecture for a host in a computer network. So for that, a typical node or a workstation architecture consists of CPU, cache, memory, and network adapter. These are connected, or we can say CPU, cache, and memory are connected through I/O buses to network adapter, and network adapter is further connected to a network. So through here you can use a UTP cable or some wireless medium to connect this particular node to some other node and to connect to any switch or router. So what are the issues that may impact the performance of a network? So the first issue in a workstation architecture is that memory is always finite. If you have a very good node, or we can say you have a sophisticated or an updated node, still memory is finite. That is, buffer space is always limited for packet storage. The second possible issue is that network adapter, the device driver basically managing the network adapter, which is using I/O bus to connect with the network system. So the network adapter is further connected through I/O bus with the CPU, cache, and memory. The third important issue in a network workstation architecture is memory access, because memory access is much slower than the CPU speed, so it may also impact the network performance. Now what may be the possible issue in links that could impact the network performance? In links we have a variety of links. we have a twisted pair cable, we have a coaxial cable, fiber optic cable, and we have a free space communication like wireless. So media is used to propagate signals. So signals are electromagnetic waves of certain frequency traveling at the speed of light. So our ultimate objective is to transmit the signal of whatever frequency on the media, and for that we need to modulate the signals. Why we need modulation? Because to make the signal distinguishable at the receiver end by varying amplitude, phase and frequency. Basically we have data in the form of 0 and 1, and we encode this binary data in the form of signals to make it appropriate for transmitting over the medium. Through encoding mechanism, the receiver distinguishes what has been sent by the sender, or to make it understandable for the receiver, you modulate the data and you convert this 0, 1 to some sort of signals. In the computer networks, we have a multiple of encoding schemes such as RZ, NRZ, bipolar AMI, and so on. So after transmitting the link may be a full duplex, half duplex, or simplex. Then the type of medium, because we have multiple choices. We have a twisted pair cable, we have coaxial cable, fiber optic cable, or we have some lease line which is normally acquired from telephone companies. However, there are further possibility in the lease line. It may be DSL, MPLS, and so on. Like a full duplex, half duplex. The bit stream may be transmitted both ways at the same time. We can say simultaneously transmission in both directions, full duplex, and sometimes two nodes must alternate link usage, a half duplex. So it's not a simultaneous transmission, but you can transmit on both direction in half duplex. Simplex is communication mode in which the sender will always transmit and the receiver will only receive the signal. Which link we should use for computer networks? So we have a variety of choices. We have a Cat5 twisted pair cable. Nowadays we have a Cat6, even a Cat7, and Cat7 extended is always also available in the market. And the typical bandwidth for these particular twisted pair cables are 10 to 100 Mbps and even beyond 100 Mbps, and the distance between the two nodes may be 100 meter. For an coaxial cable we have two choices. One is thin net and the second one is thick net. And thin net, this is basically the black cable which can be used in a cable TV or like in a cable networks we normally use in our homes. So in thin net, it is the possible bandwidth may be vary from 10 to 100 Mbps up to 200 meter. In thick net it could be 500 meters. In fiber we have two choices. We have a multi-mode fiber and even we have a single mode fiber. Single mode fiber is normally used for backbone networks when the distance between the transmitting and receiving end is very large. So it could be up to 40 kilometer without using any repeater or regenerator or booster, any amplifying device. So multi-mode fiber is provide you 100 Mbps bandwidth, and the distance between the nodes may be between 2 kilometer. So I think this is a typical link of a local area network. So we have a variety of choices in links. We can also use last mile links. Maybe we have a lease line links, and we have a last mile links. These lease lines link are basically acquired normally from the telephone companies. However, there are further possibilities in these lines, like we have DS1, STS1, STS3 and STS12. DS1 and T1 provide you 1.5 megabits per second, and this is 44 and then 51, 155 and 622 up to 2.5 Gbps. It may be a single link, or it may be you can say that multiple links can be connected to a main network, so it may vary. And we can also use last mile links. This is the most economical link for the end user, not for the network service provider, only for the end users or for the customers. So it means that network is already available, and you just need to connect to that particular network. However, for example, if the network is already available and you just need to connect through that particular network, so you can use this last mile links. In the last mile links, we have further a lot of possibilities. We have ports. Ports is basically plain old telephone services. That is, we can say, ordinary telephone service. And we have a ISDN, integrated services digital networks, XDSL, and cable TV network, Cat5 basically. So these are the bandwidth for these particular link, and we can use these last mile links as well. And further we have ADSL, asymmetric digital subscriber line. Connect the subscriber to the central office via the local loop, and bandwidth depend on length of local loop. For example, asymmetric means that the downlink bandwidth is always greater than the uplink bandwidth. So if in ADSL, if the distance between this central office and subscriber premises increases, then the bandwidth will be decreases. So bandwidth depends on the length of local loop. Also we have a VDSL, very high data rate DSL, and connect the subscriber to the optical network that reaches the neighborhood, runs over short distance, and this is basically a symmetric transmission between the sending and receiving end. It is a very high bandwidth link. If you need multiple access, so then we can use like in a cable TV. Cable TV, that is, use existing cable TV infrastructure, and this is normally reaches 95% of household in US. Single Cat5, we can say a cable TV channel has bandwidth of 6 megahertz and can be used in asymmetric wave. Asymmetric wave means that there might be a difference between downlink and uplink bandwidth, and currently achieved on a single channel 40 Mbps downstream and providing 20 Mbps for upstreams. So if you need multiple access on a shared channel, that is possible with the IEEE 802.14 standard. So these were the guided medium. In the unguided medium or in the wireless link, we also have a variety of we also have a fiber optic communications optical link that is high bandwidth, superior attenuation propagation, immune for electromagnetic interference. There are very less interference in the fiber optic link, and no crosstalk between fibers, then and lightweight and cheap, the fiber, not the optical electromagnetic interface. There is, we can say that one-time installation charges for fiber optic cable is very high comparatively, and further the splicing and the hardware for optical fiber communication is very expensive. So this is, we can say that you cannot connect a normal computer network through optical communication. However, you can connect the backbone, and you can provide the backbone connectivity through optical communication. Then we have some possibility in a wireless link. first we have a satellite link. Initially it initially targeted device communication. However, currently, as we know that we normally require data content, so it can provide a high bandwidth, but there is always issues of latencies. We can say that it can provide up to 1000 Mbps, and through geostationary satellites, and through low orbit satellites it can provide you 400 Mbps, but there is always issues of latency and in the satellite communication link. So you can use in areas where you cannot provide the normal communication. So in those particular area we can connect multiple devices through satellite link. We can also use a radio frequency or infrared frequency links, and as we know that we normally use a Wi-Fi 802.11a, 802.11b, and using ISM band 2.4 gigahertz, even we can use 5.2 gigahertz. We also have choices for Bluetooth, and these days Bluetooth is commonly used, as we have multiple choices in Bluetooth as well. Currently Bluetooth 5 is available, and we have infrared, but however the distance between the nodes might be less comparatively as compared to Wi-Fi. We can say 802.11ab. So these were the links we normally use for computer networks nowadays. In the coming important topic for this in this particular chapter is encoding, and we will cover that particular topic in the coming video.